Hey guys, so this lesson's on using the Pythagorean theorem to find the distance between points. And what I want you to start out doing here is hit pause on the video. Once you've hit pause, read through the essential question I can statement. Circle at least 2 words in each statement that you think adds to the meaning the most. That helps you understand what the question is, what the I can statement is. And I'll be coming around looking for those 2 circled words. Go ahead and pause it now. Okay, so hopefully you paused it, circled 2 words in each phrase or question or statement. And now we're going to go on to just really one example here. It's pretty slick. So we're kind of making up something as we go here. We're going to, and you have to forgive the pen's not working very well, so it's kind of choppy. So we've kind of made up this example, or I made it up. What's the distance from point to point? So let's call this point Z. Whoops. Point Z. Let's call this point Y, just for fun. Okay, so the question is, what's the distance? Now, I realize that this is a made-up example, but I'm going to show you how to do this with made-up examples, and then hopefully we can apply that to some tougher problems that we might run into in the real world here in the next few days. But today, we're going to kind of come up with these fake problems here that will help us understand real-world problems. So we got these points here that we made up, and so what's the distance between them? Well, to figure this out, you kind of need to imagine an imaginary triangle. An imaginary right triangle, and we can actually draw it. You might be wondering, well, why? Why would we draw this? Well, you'll notice hopefully right away that when I drew that, I formed a right triangle which would allow us to solve for the hypotenuse because I know how long this is. See, this is 1, 2, 3, 4, 5 units long, and this here I believe is 8. 1, 2, 3, 4, 5, 6, 7, 8 long. So if I know this down here is 8, and I know this on the side here is 5, I can use the Pythagorean theorem. Remember that a squared plus b squared equals c squared thing? Remember this? I can use that to solve for the hypotenuse, which kind of is pretty handy actually. Okay, there we go. So I can just use that. So I know that this line segment over here, that from Z to Y, is going to be considered C because it's the hypotenuse, right? And so we just plug the numbers in. So we plug in the 8 right here, and we square it. My pen's really not letting me draw very well here today. Might need to update some software. Plus 5 squared. Now, it doesn't matter if I put the 5 or the 8 in different places. Remember that. You can mix up the legs, okay? And so I end up with 8 squared, which is 64. Plus 25. Oh gosh, let me erase this. I'm just going to type it. This pen is like killing me. Okay, so we end up with 64 plus 25, which is going to equal our c squared still. Okay, and so now I'm just going to use a calculator from here on out. I'm going to add 64 and 25, and I get 89. Now I know 89 is not my answer. I got to take the square root because I want to know what c is. So I take the square root of 89 and I get 9.433981. But I can round that. And I'm going to go ahead and round that to the nearest tenth just because. So I'm going to say that c is about 9.4 because we round down to 9.4. So what's the distance between point Z and point Y? It's about 9.4 units long. And that's really all there is to it. So let me give you some steps in written form. If you're one of those people that like to have steps written out in words and sentences, this next slide is there for you. But before I do that, let's quickly recap what we did because some of this writing got kind of sloppy, kind of messy. Okay, so we started out with just knowing where point Z and point Y were, and we wanted to know the distance between them. So we drew an imaginary line here, an imaginary line here to form a right triangle, and we knew this was 8 because we could count that it was 8. We knew this was 5 because we could count it was 5. But we really can't count this line segment because it's not perfectly through squares or perfectly level or perfectly straight. Because remember, this right here would be considered 1, but the diagonal of one of these squares is more than 1. It's longer, right? So that's an interesting little point to remember. So we use that information to calculate this distance at being 9.4. So here's the next slide. If you want to copy these steps down, go ahead and pause it, copy them down. If you're not going to copy these steps down, you need to take them and put them in your own words. So maybe it's draw a right triangle, use a Pythagorean theorem. Maybe it's that simple. But you need to do that on your note taker. I need to see that when I come around. Okay, finally, before we're done here, I want you to practice. I want you to hit pause in just a second, and I want you to try and find the distance between this point here and this point here. And I first want you to start on your note taker. There's like an XY axis that I copied down there on the upper left. I want you to graph this, and then I want you to draw your own triangle and give it a try. Then I want you to hit play after you have your answer, and you'll see how I do it, and you can compare your work, okay? So hit pause now and try and find the distance between those points. Okay, so hopefully you've hit pause and solved it, and I'll quickly take you through how I did it, and I'll do it fast. So I'm going to draw my imaginary triangle. I know that it's 1 from here to here, and I know that it's 3 from here to here. And I'm not going to be able to write too well, so I might skip some of the algebra steps. Let me give the marker a try. So I know this is 1, this is 3. So I know if I plug that into a squared plus b squared equals c squared, that my a and my b are going to be the 1 and 3, and it doesn't matter where they go. So I'm going to have 3 squared plus 1 squared equals c squared. And what I'm going to end up with, whoops, that's supposed to be a 2. What I'm going to end up with is 10. And I end up with 10 equaling c squared because this is 9, 3 times 3, and 1 times 1 is just 1. So I have 10 equals c squared, right? Whoops. 10 equals c squared. So now I just take the square root of that, and I'm done. So I come down to my calculator. 10 square root 3.2. I'm rounding to the nearest tenth. So the line segment here was 3.2. That's the distance, 3.2 units between these points. And I hope you got that answer. If not, raise your hand and I'll help you. Thanks, guys. Good luck. The assignment's on the other side of your note taker. And if it's not done in class, it's homework. So get it done. All right, bye.